Do you want to excel in maths and science? If your answer is yes, then let me tell you, go ahead with Infinity Learn courses. And to get best discounts, subscribe right now. The link is given below in the description box. Hello my dear students, welcome to my channel, and as you all know that I am Divya, your science expert, and today I am up with very interesting and amazing topic from chemistry, and it has been taken from chapter chemical bonding. So particularly we will discuss about Lewis symbols. But before we move ahead, I have offering news for you that if you go and buy the course, then you can make use of coupon code DE10, and you won't believe that you will get extra 10% discount. So why to waste time? Just go and buy the course and do not forget to use my coupon code DE10. So let's begin. Okay, activity time is always a fun time. Tell me, what is it? It is clearly mentioned, and you know this, that it is periodic table of elements. Like we have so many elements discovered so far. So in order to understand them properly, in order to know about their properties, we that periodic table is formed where all the elements, they are arranged in a definite pattern, right? So this complete is a periodic table where you can see the arrangement of the elements. Now in the periodic table, the elements are arranged on the basis of fundamental property, that is atomic number, right? Like hydrogen has got 1, then helium 2, then 3 to 10, so on. The elements are arranged as per the atomic number. One amazing thing you will find here, that all the elements belonging to same group, like you know that these vertical rows are groups and these horizontal rows are pairs. So all the elements in one group, they have same valence electron. So all the elements which belong to group 1, they have got 1 as a valence electron in them. Okay, I'll just show you the electronic configuration. See, the first group is helium, hydrogen, lithium, sodium, right? So if you write the configuration, it will come out to be like this. Okay, that is, you can see that all of them have 1 as valence electron, and as we move down, every time a new shell is being added. Same way, if we move in a horizontal row, then what you will see, let me take this second horizontal row, that is second period. So if I write the configuration, let me write the name of the elements first. If I write the configuration, you will see that all of them, they have same shell. Like all the second period elements, they have got L as a valence shell. So all of them, they have 2 shells, right? And if you'll see their electronic configuration, you can very well notice that shell remains same, the number of shell remains same, but every time a new electron is added into a same shell. So this periodicity we can see in the periodic table, and it is responsible for the periodicity in properties also. Now let me tell you about one very interesting thing. We know that 18 group belongs to noble gases, right? That is helium, neon, argon, krypton, xenon, radon. These all are noble gases. Now if we'll see their electronic configuration, you will see that all of them have 8 as valence electron, and all of them obey octet rule. And you know that if anything obeys octet rule, that is tendency to have 8 electrons in the last shell, that means stable valence shell, stable electronic configuration, and those elements, they don't have to combine with some other atom. They are stable. That is the reason inert gases are stable. They are inert. They don't react with any other thing because they have got stable noble gas configuration, or they have got stable configuration as their octet is complete. Okay, let's move ahead. So we have understood that all the elements of same group, they have same valence electrons, and when we move in the same period, they have same number of shells, but valence electron increases by 1. And noble gases, they are stable because of their stable electronic configuration. So you should know that all the elements which are not stable, right? So they are looking for stability. So how they can be stable? By combining with some other atom. And when they combine with some other atom, then they linked up by a chemical bond. That linkage is called as a chemical bond. So all the atoms in a molecule or in a compound, they are held by a force, linkage. That is called as a chemical bond. Now you should know that whenever two atoms, they tend to combine with each other, always, whether they are forming any sort of bond, always and always, valence electrons, they participate. Always the valence electrons participate, that is the electrons present in the last shell. For example, in case of sodium, you know that the configuration is 281 because number of electrons are 11. So 2 electrons in K shell, as you can see, 8 in the second shell, you can see, and 1 in the third shell. So that means KLM, M is the valence shell. So only 1 electron is going to participate. Right, same way in chlorine, the configuration is 287. Outermost shell electron has 7 valence electrons. So only 7 is going to participate in the bond formation. Okay, and whenever the bond is formed, let me tell you, out of valence electrons, only the valence electron participate. So you should always remember that the inner electrons, they remain unaffected during the bond formation. Now, chemical bond can be defined as, in a simple way, linkage which holds 2 or more atoms together in a molecule. For example, this you can see CH4, that is methane. So this, these indicates the linkage, that how 4 hydrogen atoms, they are joined up with the central atom, which is carbon. So the cause of chemical bond is very clear, is very transparent, that every element need to attain stability. To become stable, what they do? They either lose or gain or share electrons, and by doing so, they complete their octet and they become stable. And only the valence electron participate, do not forget this thing. Now Lewis is the scientist who explained us that during the bond formation, how can you show the valence electrons? Because only the valence electrons are going to participate. So there has to be certain representation of valence electrons. Okay, and they should look different from the other electrons. So they said that whenever the chemical bond is formed, whenever you are writing any symbol of any atom which is participating, so you can always show its valence electrons with the help of dots. And those dots are put around the symbol of an element. Right, so valence electrons are always participating in bond formation, it's clear. And how we can represent them? We can represent by putting dot where? Around the symbol. I'll show you, don't worry, how to do it. Let's practice together. See, I'm doing as per the atomic numbers, okay? So let's write first the atomic numbers of at least 1 to 20. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. Then you have oxygen, fluorine, neon. Then you have sodium, magnesium, aluminium, then silicon, phosphorus, chlorine, then you have sulfur, then you have, silicon, phosphorus, 14, 15, 16 is sulfur, sorry. And then 17, then you have 18, then you have 19, and then you have 20. Okay, so if I write their configuration, this is 1, this is 2, this is 2, 1, this is 2, 2, this is 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. I hope you all know how to write the configuration. And please make sure that when you write the configuration, separate them with commas. That is must. Okay. So it's 285. Sulfur is 286. Chlorine is 287. Argon is 288. Potassium is 2881. And calcium is 2882. So obviously in all of them, only the valence shell electrons are going to participate. So how we'll show it? It has 1 electron, I can show by 1 dot. Helium has got 2, I can show it by 2 dots. Otherwise, it doesn't participate in bond formation because it is inert. It's a noble gas. Lithium, I can show with 1 dot. Beryllium can be shown by 2 dots. Okay. Boron can be shown by 3 dots. Carbon can be shown by putting 4 dots like this. Nitrogen can be shown by putting dots like this, 5 dots. Oxygen 6, you can represent like this. Fluorine 7, you can put them in pairs, become 6, and this is 7. Neon is inert, so all the, with the 8 1, they can be shown like this. So it will not participate. Sodium 1, so again you can repeat So again, you can repeat like this, the same way you used to represent, 1 to 8 as a valence electrons. Okay, now these are few examples I've already given. See, hydrogen, calcium 2 dots, aluminium. So one thing I want to tell you, that suppose if an atom has 7 dots, let's say chlorine, please do not decorate it with like this. You have to put them in pairs, proper pairs. Your dots should be well distinct. Okay, so this is how we show it. Now these are the molecules. I'll give you an explanation how we show Lewis dot in that case. Okay, let's show the bond formation of aluminium and oxygen. We know that aluminium is a metal and oxygen is a non-metal. So obviously the bond formed will be ionic. Let's start with metal. 13 configuration and 13 atomic number and configuration 283. So 3 electrons are going to participate. So I can show 3 electrons like this. It will lose 3 electrons. And after losing, you know that it will form Al3 positive and it will become aluminium ion with configuration 28. Now oxygen 8 atomic number, configuration 26. We have to show 6 electrons. So put dots like this. It will take 2 because then only it will become stable. So overall, what has happened? Aluminium with 3 valence electrons, oxygen with 6, and what they form? Al3 positive and O2 negative. You crisscross, the valencies are crisscross and Al2O3 is formed. So this is how, you can show and, the valence electrons in the form of dots. Now let me tell you about the covalent bond. Methane is CH4. Central atom is carbon and we know that atomic number is 6, configuration is 24. So it has got 4 valence electron, and hydrogen 1, configuration also 1, valence electron also 1. So 4 hydrogen are combining. So we'll arrange the 4 hydrogen around this carbon. All of them has 1 valence electron. So we'll indicate by putting 1 dot with each hydrogen. Now carbon has got 4. So we are splitting its valence electron this way that each valence electron is facing hydrogen. Now this hydrogen attains duplet, even this and even this. And this carbon has its own 4 and 4 it has taken from 4 combining hydrogen. So this is how you can show the bond formation using Lewis dots. And one thing very important in case of double and triple bond, for example in carbon dioxide. So carbon dioxide is formed this way, I'll tell you. Carbon has got 4 valence electron and each oxygen needs 2. So carbon will put 2 facing 1 oxygen and 2 facing 1 oxygen. 4 complete. And same for oxygen, it has got 6. It needs 2, so it will put 2 facing carbon. Same with this one. Now 6 and 2, 8. 6 and 2, 8. And 4 and 2, 2 from each carbon becomes this. Right, so in case of double and triple bond, you show in a similar way. Same if you want to form for ethyne, ethyne can be formed like this. Right, so if you'll see the electron cloud, how it is covering, it is simply like this because one electron pair makes up one bond, one covalent bond. Like this you can show it. And also if you want to show the the overlapping, how they are sharing, then you can show it this way. 2 and this 6 and 2, 8, and same 6 and 2, 8. This is how the bond is formed. So in the case of double and triple bond, you show it again by using valence electrons as dots. So this whole concept of putting dots around the symbol was explained, well explained I must say, by Lewis. So please, whenever you are showing any sort of bond formation, use these dots. Okay, that is mandatory to use. So with this we have come to an end. I hope you have understood the concept thoroughly. Practice it more and more and more and stay connected. Thank you. Take care. Bye bye.